Good morning, one and all. Let us have a presentation today on optical fiber communication. I am Dr. Shankar R, a professor in the Department of Electronics and Communication Engineering, Tigala Krishna Reddy Engineering College, Hyderabad. Before we get into the details of optical fiber communication, let us have an outline of this presentation. This presentation has an introduction where we will know what is optical fiber communication. Next to that, we shall see a detailed discussion on light propagation in optical fiber communication, where we will be knowing what is total internal reflection. Next to that, we'll see various types of fibers that are being used in optical fiber communication and in what way we are going to have wave propagation inside our optical fiber communication. Next to that, we'll see the black diagram of optical fiber communication system, followed by various elements of fiber optic communication or optical fiber communication system. And we will also discuss benefits or advantages of optical fiber communication system and their applications. Before completing this presentation, we will see the scope of optical fiber communication system in this presentation. Most of us may come across pictures like this. The one at the top and the one at the bottom may be seen as a front page of most of the optical fiber communication system books. So what does this? So this indicates fibers. So the fibers are the medium through which light signal is being taken from transmitter to receiver. So in this way, each and every fiber are going to have some light signal. Okay. So that is why the medium, that is fiber, which is having signal from transmitter to receiver in optical fiber communication system, is given most importance in optical fiber communication system. Now, let us get into the introduction of optical fiber communication. So as I said just now, optical fiber or fiber optic communication system sends information by using light signal in terms of pulses through an optical fiber, which is a medium in our optical fiber communication system. So here in this picture, we may see this is the source from where our information is being sent to the other side. For example, the user that is present at the other side of this communication system. So this source is going to send its information through a transmitter. This transmitter is going to have signals in terms of electrical form, and this electrical signal are going to be converted into our optical signal by means of various process. And through this connector, this is going to be connected. That is our transmitted signal that is going to be sent by our transmitter is going to be connected to the optical fiber cable. The optical fiber cable or fiber optic cable are one and the same. Optical fiber cable or fiber optic cable are one and the same. This is going to act as a medium between our transmitter and our receiver. Okay. So in the optical fiber cable, our signal is going to be in terms of pulses. So light pulses or light signal is going to be carried by our optical fiber cable or fiber optic cable, which are one and the same. So this optical fiber cable is going to be connected to both our transmitter at the sender side and receiver at the receiver side. So in this way, our optical fiber cable or fiber optic cable, which is the medium that is connecting our transmitter and receiver, responsible for taking our signal from source to the destination or the user intended to. Okay. So this is how our optical fiber cable plays an important role in our communication. That is why this communication is being referred by means of optical fiber communication or fiber optic communication. Of course, this includes transmitter and receiver. Thus, it's a system where your communication is going to happen because of our optical signal. Okay. In this way, digital data is converted into light pulses in optical fiber communication system, where the presence of pulse represents a binary 1 and the absence of a pulse represents a binary 0. So by now you may understand our information, which is in terms of ones and zeros, are going to be transmitted by means of light pulses in terms of presence or absence of pulse. So that is how the light is modulated to carry the information, creating an electromagnetic carrier wave. Here, the light is the carrier which carries our information, which is in the form of digital data, ones and zeros. So this is being done by our optical fiber cable, which is a cylindrical waveguide that operates only in optical frequencies. So this is the optical fiber cable or fiber optic cable that operates at optical frequencies. That is nothing but our light signals. Parallel to its axis. That is here, parallel to its axis, it will have the light inside our optical fiber cable. Now, let us see how our optical fiber cable is going to have its structure, right? So I have two pictures of optical fiber cable, one at the top and the other at the bottom. Let us see from the bottom. So this is the outermost jacket that is going to give some strength to the optical fiber cable. This outer jacket is going to prevent other disturbances to the signal present inside the optical fiber cable. And next to your outermost jacket, we are having a strength member which adds further strength to your optical fiber cable. And next to our strength member, we are having a coating which is going to protect our optical fiber cable. And next to that, you are having a cladding, and inside the cladding, we are having our core, where we are going to have our light signal sent from transmitter to receiver. So it is the core where our light signal is going to be sent from transmitter to receiver, which is protected by a cladding and which is further protected by a coating, and further it is going to be given strength by some strength member and outermost jacket. Now coming to the next picture, which is going to be there for seeing how our optical fiber cable is. See, it is how our core, which I told, is going to have a light signal present inside, and this light signal is going to be launched from our transmitter side towards our optical fiber cable, right? So this light signal is going to be sent inside our optical fiber cable in terms of a parallel signal, right? So, and the core is going to contain the entire light signal from our light signal being lost to the other structure of our optical fiber cable, right? So next, so your core is going to be given some protection by this cladding, and the cladding is further going to be given some plastic coating, which is going to be there in our optical fiber cable, that is going to give some even more protection, right? So from this, we may understand in our core, we are going to have our light signal like this in both the pictures. In the core, we are going to have our light signal, and inside the core, it is going to be contained by the core because of some different refractive indices that is going to be there for core and cladding. So that we will see afterwards while we are discussing our total internal reflection. And we are having another layer in our optical fiber cable that is nothing but a protective layer, which is going to be a plastic coating, which is a simple plastic coating that is going to be like this, or either a strong plastic coating that is going to be there with this outer jacket, which is going to protect the optical fiber cable structure, that is both cladding and core, and the light signal that is present inside our core, right? Shall move on further. So in this picture, again, I have shared two pictures for understanding. So one at the bottom and the other one at the top. Okay. So it is how our optical fiber cable is going to have our information. So our information in terms of English language here, that is group, is going to be in terms of its digital data, ones and zeros, that is shown in this picture. So these ones and zeros are going to be sent in terms of presence or absence of pulses, either high value of light signal or low value of light signal. Okay, so this is how we are going to have our light signal sent through our optical fiber cable from transmitter to the receiver. So it is how the information, as I used to convey here, group, which is converted into its digital representation ones and zeros, is going to be sent by means of intensive pulse, light pulse, which is going to have higher amplitude or lower amplitude from the transmitter to the receiver, right? So it is how the core of your optical fiber cable have this intensity, that is light density, which is nothing but light pulse, which is going to be sent from transmitter to receiver, right? Correct? Let us move on to the next slides to understand further. So here also again I have shared two pictures of optical fiber cable. So at the bottom we are having a optical fiber cable which is having core, and this is our core, and this is our outer cladding structure of our optical fiber cable that is present around our core. So inside our core we are going to have this light signal. So this light signal is going to present inside the optical fiber cable core based on the data that is being sent from our transmitter to receiver. So if it is 1, it is going to have a high pulse light, whereas if it is a 0, it is going to have a low pulse light. Right? High pulse light I conveyed is here about our high intensity of light signal and low intensity of light signal based on the ones and zeros present in our data. Okay. So now let us move on to the picture that is present at the top. So again, here it is our core, and around it we are having our cladding. So it is our core, and around it we are having our cladding. So inside our core we are going to have our light signal. So this is our light signal that is going to be launched inside our optical fiber cable. This launched optical fiber cable's light is going to move towards the other side, that is towards the destination, because of some property of light. So that is nothing but about total internal reflection that we will see in the next slide. So what is total internal reflection? So this total internal reflection is going to contain our light inside our core. So rather going out of our core to the cladding or to the other other layers of our optical fiber cable, our total internal reflection is going to contain our light signal inside our core. So otherwise, without total internal reflection, we can't have our light signal contained in our core, and it can't have our light signal received at the receiver without any loss, right? So how this total internal reflection occurs inside the core, we will see in the next slide, right? Let us move on further to know more about total internal reflection. So by now, we came to know that our optical fiber cable is having light inside the core. How light is present only inside the core? Of course, I told you it is because of total internal reflection. Now, we need to know what is total internal reflection. So it is through this total internal reflection only, we are having our light propagating through a fiber, right? So what is this total internal reflection? Of course, this total internal reflection is a property of light. Okay, what is this property? Let us see. When a light ray incident at an interface between two mediums with different refractive indices at an angle greater than the critical angle, it undergoes total internal reflection within the medium of higher refractive index. Let us see a picture to understand more about this total internal reflection. Right. So now consider these two mediums. So the first medium is water, the second medium is air. The first medium is having refractive index as N1 and second medium air is having refractive index as N2. Okay. So when a light falls at the interface between water and air. So when a light falls between the interface of water and air, this light is going to present at air if the angle of incidence is less than the critical angle. Whereas if the light falls at the surface or at the interface between your air and water at an angle of critical angle, then there won't be any reflection at the other medium. That is, from water, if light is incidenting at the interface between water and air, there won't be any reflection at the other medium, that is air. Whereas in the next case, when light incidence at an angle θ1, which is greater than critical angle at the interface between water and air, which are having refractive indices N1 and N2, where N1 is having higher value and N2 is having lower value. As the angle of incidence is greater than the critical angle θc, this entire light signal is going to be reflected back from the surface or interface between these two mediums, that is water and air. So this light signal that was incidenting to this interface between water and air is going to be totally reflected back internally towards the water again, okay, at an angle θ2. So this is how our light is going to have a property which is going to have our light reflecting back to the same medium, which is having higher refractive indices when it is having an angle of incidence greater than the critical angle. Okay, so it is how we are going to have total internal reflection in the same medium which is having higher refractive indices. Okay, so this is applied here in our optical fiber cable. Now you just consider this as an optical fiber cable. So this tube-like structure is our core. Okay, so around this core we are going to have our cladding. Okay, so that cladding is going to have comparatively lesser refractive index as like our air here. Okay, so this core is having higher refractive indexes as like our water here. So our refractive index is going to be higher for our core and lower for our cladding. Okay, so when this higher refractive index core and lower refractive index cladding is receiving a light signal. Okay, so this light signal is going to be reflected back into the core at the surface of your core and cladding. Okay, so it is how your signal that is going to be present at the surface of our core and cladding is going to get reflected back into the core, and it is going to travel over your optical fiber cable as a parallel light signal to the axis of our optical fiber cable. Okay, so this is how a light that is entering into the core is going to travel inside the core by means of total internal reflection at the surface of core and cladding, and it is going to have a parallel path to the axis of our optical fiber cable, and it is going to leave the optical fiber cable at the other side, right, at the destination side, where that destination side receiver is going to collect this light ray and process this light ray, and it is going to convert the light ray into its equivalent electrical signal that is going to have our information in terms of zeros and ones. Okay, based on the communication system. Okay, let us move on further. So in this case, we will see the condition for our total internal reflection. So by now, we would have understood how our total internal reflection occurs in our optical fiber cable. It is because of two refractive indices that is there between our core and cladding. where our core is having higher refractive indices, whereas our cladding is having a lower refractive indices, and these two varied refractive indices is going to get the introduction of our property of light that is responsible for our. So this total internal reflection occurs at the following conditions, like when light is incident on the dielectric with lower refractive index from dielectric with higher refractive index, and when the angle of incidence exceeds the critical angle, then our total internal reflection happens, right? So though total internal reflection is there, it will occur only when angle of incidence is greater than the critical angle, right? So it is about total internal reflection. By this time, everyone would have understood how our optical cable core is having our light contented into it. It is because of our total internal reflection that is going to be there because of varied refractive indices of higher refractive index with core and lower refractive index with cladding, right? So now let us move on to the next slide, which shows the types of fiber in optical fiber communication. So based on the usage in communication, optical fibers can be classified into two types. First one is step index fiber. The other one is graded index fiber. So in step index fiber, we have further two types, which are nothing but single mode and multi-mode. Whereas in the case of graded index fiber, we are having only one type, which is nothing but multi-mode. So let us see what is step index and what is graded index through some pictures, right? So it is our step index fiber where our refractive index is going to have varied values. So by now we know our core of the optical fiber cable should have higher refractive index and cladding of the optical fiber should have lower refractive index for having our total internal reflection, right? So in our step index optical fiber cable, the same is ensured, but this is going to be there in such a way that there is an impulse or sudden change in index between core and cladding. See, this is the value of core's refractive index and this is the value of cladding's refractive index. Okay, so it is the radial distance from the center to the outermost region of our optical fiber cable. So it is there with respect to our step index optical fiber cable. Whereas coming to the graded index optical fiber cable, the same refractive index with higher value is going to be there for our core and lower refractive index is going to be there for our cladding. But in this case, it is not going to be a steep variation between core and cladding like our step index optical fiber cable, whereas it is going to be a gradually varying refractive index in the case of core and a constant value of refractive indexes in the case of cladding. So compared to this cladding here, again, there is a increased value of refractive index in the case of core of graded index optical fiber cable. Okay, so it is how your core and cladding refractive indices is going to vary in our step index and graded index optical fiber cable. So what is the outcome? What is the result of this varied refractive indices of core and cladding in step and graded index optical fiber cable? Let us see. So before that, we have seen there are two types of step index fiber, which is single mode optical fiber cable, that too single mode step index optical fiber cable and multi-mode step index optical fiber cable in step index optical fiber cable. So let us see what is this in terms of its picture, right? So in the case of single mode optical fiber cable, we can have only one optical signal present in the core of your optical cable. Okay, whereas in the case of multi-mode step index optical fiber cable, we are going to have more than one optical signal present in the core. Okay, so this is how we are going to have more number of signals transmitted inside the step index multi-mode optical fiber cable, whereas in the case of single mode step index optical fiber cable, we are going to have only one signal present in the optical fiber cable. And coming to the graded index optical fiber cable. As we have seen, in the case of graded index optical fiber cable, there is only one type, which is nothing but multi-mode optical fiber cable. So in the case of multi-mode graded index optical fiber cable, our varied refractive index of our optical fiber cable in graded index optical fiber cable is going to have varied shape or varied path for our optical fiber cable for its signal. Can you follow? So in this way, we are going to have more than one signal present in graded index optical fiber cable. Because of this varied refractive index, the core is going to have the path of your optical signal inside the optical fiber cable like this. More than one signal is going to present and their path are going to be like this. Okay. So in this way, more than one signal, more than one light signal is allowed in both multi-mode step index optical fiber cable and multi-mode graded index optical fiber cable, whereas it is not so in the case of single mode step index optical fiber cable, where we will be having only one signal, only one light signal allowed or present inside the single mode step index optical fiber cable. Okay. So based on the requirement, we are going to use the optical fiber cable in the communication system. As I told in the beginning, this optical fiber cable is going to be a medium or a channel between our transmitter and receiver. Okay. If it is required to be present between dedicated two people, then it is enough to have our single mode optical fiber cable. So if it is going to be between two varied number of users, then we will be going with multi-mode step index optical fiber and multi-mode graded index optical fiber cable, right? So now let us move on to the next slide. Let us move on further. By now, we got some idea about what is an optical fiber cable and what is the property that allows our light to travel over our optical fiber cable and what are all the different types of optical fiber cable. With this, we can get into the details of optical communication system, that is fiber optic communication system or optical fiber communication system, which are one and the same, right? So optical fiber communication system. So here, the main goal of optical fiber communication system is to transmit signals containing information from source to destination or the user intended to. Okay. So like all other communication systems, this optical fiber communication system or fiber optic communication system is also going to transmit voice, data, video, and other information from source to the destination. And in this case, your signal is going to be in terms of light. So that is the main difference between other communication system to this optical fiber communication system, right? Let us see the black diagram of the optical fiber communication system. So it is the black diagram of an optical fiber communication system where you can see it can get the input from an analog device, and that analog device input is going to be converted into digital by means of analog to digital converter, and that signal is going to be given to the processor present in the transmitter of our optical fiber communication system, whereas our digital device in digital communication system is going to directly give the digital signal to the processor, and this processor is going to process the signal, which is going to be in terms of ones and zeros, either from our analog device through our A to D converter to the processor or from our digital device to the processor. Okay. So based on the ones and zeros values present in the information, this processor is going to give instruction to give out light signal or light pulse. So to the light emitter that is present in the transmitter. Okay. So this light emitter can also be called by means of light emitter and transmitter. So that is going to emit light when there is one present at the input, whereas it is going to not emit any light when there is a signal 0 present at the input, right? So in this way, ones and zeros are going to be transmitted over our optical fiber cable in terms of light pulse, either presence or absence of light. Based on the length of optical fiber cable between our transmitter and receiver, there may be requirement of repeater and regenerative part in optical fiber communication system. So in repeater or regenerative part, our signal from the optical fiber cable, which after travels a long distance, will have a reduced strength, will be amplified by this setup. So where we are using our light detector circuit, which detects the light present in the optical fiber cable, and it is given as an input to the amplifier circuit. This amplifier circuit boosts the corresponding signal that is going to be there for the equivalent light signal, and this circuit is going to give the input to the light emitter and transmitter that is very similar to our light emitter and transmitter present in our transmitter circuit or transmitter part of our optical fiber cable. So again, this light emitted by the light emitter and transmitter is going to be sent over a long distance or the distance at which we are going to have our receiver, right? So here again, this signal is going to be an optical signal carried by our optical fiber cable, and this signal, which is in optical form, is going to be converted into its equivalent analog or digital form by the receiver. So the reverse process that was done by our transmitter is going to be done here in the receiver. So light detector circuit detects the circuits. Light detector circuit detects the light present in the optical fiber cable, and it is going to give the input to the amplifier circuit, and this amplifier circuit is going to give the input to the shaper circuit. So this shaper circuit's output is going to be given to digital to analog converter, where this digital signal given by the shaper circuit is going to be converted into its equivalent analog value by this digital to analog converter, and that is going to be given as an input to the analog devices. Whereas in the other case, if it is going to be a digital communication system, shaper circuit's output is directly given to the digital devices. So this is how our communication happens in the optical fiber communication system with the help of our optical fiber cable between our transmitter and receiver, or between transmitter, repeater or regenerator and receiver. Okay. So this is how our communication happens in optical fiber communication system. Now let us move on to the next slide, where we will be seeing the elements of optical fiber cable. Optical fiber communication system. In this slide, we will see various elements of optical fiber communication system. So this is the electrical part of our optical fiber communication system, where our actual source is going to give the information, and that electrical part is going to give out its input to the transmitter part of our optical fiber communication system, where we are having our driver circuit, which is going to convert our electrical signal into its equivalent light input, and this light system is going to give out its output directly to the optical fiber cable, and this light system is going to be coupled to the optical fiber cable through the coupler. So optical coupler is responsible for coupling our optical fiber cable and light system part of our optical fiber cable, right? So in this way, we are going to have our optical fiber cable protruding out of our transmitter part, and this optical fiber cable is going to have different paths based on the requirement. So here it is going to be given to the optical fiber cable is going to be connected to the regenerator or repeater. So where our optical signal is going to be converted into its equivalent electrical signal through this electronic part of our optical communication system, and it is further transmitted in terms of optical signal by this optical part of our regenerator, and which is going to be coupled again to our optical fiber cable, and through this optical fiber cable it is going to be transmitted to a longer distance where our receiver is available. Okay, so at the receiver, again this optical signal is going to be converted back into its equivalent electrical signal by this driver, and this output, which is going to be in terms of electrical signal, is going to be processed before given to the final user or final device, right? So that is going to be processed through amplifier, and required shape of the signal is going to be given to the electrical system, which is going to give out the information to the user, right? So in this element, we can see we are having optical signal, which are all represented by means of this two lines, and electrical signal, which are all represented by means of this single line, right? So electrical system, transmitter, coupler, optical fiber cable, regenerator circuit, and again receiver, where we are having amplifier and other driving circuits before receiving the signal back from our optical signal, are all our elements of optical fiber communication system, right? So let us move on to the next slide, which talks about advantages of optical fiber communication system. So as we know, light is a signal which is having very high frequency. It is having immense bandwidth with which we can have lot of information from our transmitter to receiver for our transmission, right? So it has immense bandwidth, and as light signal is a totally different signal from our electrical signal, we do not have any interference, electrical interference, so in the communication system. So totally electrical isolation is ensured by optical fiber communication system, and low transmission loss. As we know, our light signal is not going to weaken beyond a limit, so there is very low transmission loss, and our optical fiber cable are all compact and lightweight. So it is ensuring lightweight for the communication system, and high signal security is going to be ensured by optical communication system or fiber optic communication system. So this high signal security is going to either give the signal, or it is going to lose the signal entirely, by which we may understand something wrong has happened in the system, right? And of course, as it was mentioned already, so interference is going to be very less. So others, crosstalk between other users is going to be very less in the optical communication system. And as we are going to have our communication in terms of light, our energy is going to be used in a very less way compared to our radiation that are nothing but our radio communication, right? Whereas the scope for the system is lot and more. Okay, so capability and scalability is beyond the expectation. We need to do a lot of work in this optical fiber communication. So it has got very heavy advantage compared to other optical, other communication systems. Okay, so let us move on to the next slide, which is nothing but applications of optical fiber communication system. So in telecommunication field, we are having our optical fiber communication extensively used for long distance, high speed, and in all backbone network, which needs a lot of bandwidth. We are using our optical fiber communication system, and at the data centers, which handles large data that needs larger bandwidth with low latency, we are having our optical communication system. And in cable televisions, more number of television signals can be transmitted using this optical communication system. And in military and aerospace, as it is more secure and reliable communication, it can be used in military and aerospace. So in medical imaging, it is having high resolution images. So high precision is required in medical communication. So in this case, medical imaging is assuring its best with the help of our optical fiber communication system. And then in industrial applications, so for automation and control systems, we can rely on optical fiber communication system. And Optical fiber communication system supports IoT devices and sensors for collecting and transmitting data with lesser delay, right? And of course, in research and education also, it is being used hugely. So research laboratories are using high-speed data transfer using this optical fiber communication, right? So next, scope of optical fiber communication system. So while optical fiber communication systems have drawbacks such as fragility and challenges with the splicing and coupling, and also initial high setup costs are there with optical fiber communication systems, it is undeniable that they have revolutionized communication. So the potential for future advancement is evident. So once computers can process optical signals directly, communication could rapidly transfer towards optical technology. This prospect highlights the transformative impact of optical fiber on the communication industry. Okay. So with this, I conclude my presentation. Thank you.